we have been collecting this data for a long time. It may be imagery from cars, driving around. It can be data about, user behavior or something. And then we'll just add some code to this, and poof, you get some magic answers, and maybe increase your revenue or do whatever, or improve the experience for users or something. But like in reality, that doesn't happen. In reality, you do a lot of like grunt work just to get to a place where you can start adding value to the company existing structure. Maybe you'll start with some data that exists in some form, and you try to add code to do a model training and realize the data is not in the form you want, or the features you want do not exist, and you have to go back and forth to maybe introduce more data or collect more data from different sensors, or do feature engineering and model selection and so on. Even when you do, the data may not be in the right format for you, so you are running a lot of transformations on columns and features to be in the way you want them to be for your model to run. And even after you train the model and do some optimizations, you will then start worrying about how are people using this model for inference, and how do you want to maybe transform the inputs that you will get at runtime or serving time. And it's not like this linear flow. It doesn't happen this way, right? Like you go in a pass at this, and then you realize things are not working, and a lot of times you go back to the drawing boards or the previous step, and it's like a cycle that keeps going and going, and hoping at some point you ship something, you ship some machine learning model or some improvement to an existing one, but it doesn't end there, right? Because it's shipped code that's running in production, and data changes and the inputs change over time, and you have to constantly monitor the performance of that in production model. Is it drifting? Do I need to retrain? All of these things. The performance in real life, or if you're shipping improvements, do experiments on the real data and the new model, right? So it's an ongoing thing, and every single model you add to this pipeline is an extra cost that you have to babysit forever, right? It's not like a piece of code you just throw over the fence and be done with it. It's a living, breathing thing that just keeps, you have to keep taking care of. So it's very important to, when you ship one of those, is that you and the company, or the enterprise that's shipping this, feel confident that, of the performance, and if the quality of the data and the accuracy and so on. And oftentimes what we see is people, because to reach that confidence level, it takes them a lot of time to test and run local offline testing to make sure the quality is correct, is at the place where they want them to be. They ran this survey in 2019, and 700 or so companies, and shy of 90% of them said it takes anywhere between 4 and 8 weeks to ship a single model to production, which is insane. Just to put it in perspective, if you compare this to traditional code that we ship for, be it a mobile app or a website, in 2017, so even 2 years earlier, Facebook were building their Android app 50 or 60,000 times a day. That's just completely different scale, right? AWS were reporting they ship code every deploy to production every 11 seconds. And yes, this is different scale company. They're huge. Etsy is not that big. They're less than bet like less than 1,000 employees there. Even them, they can, it's a website, right? But they ship it 50 times a day, right? So like, if you think of your model as, piece of code that you are maintaining, taking 4 to 8 weeks to ship, like a new model or an improved model, versus shipping web-based websites 50 times a day, just like completely different worlds. I think what we are doing today with like shipping models, how we are productionizing models, is maybe more analogous to what we used to do for regular code, maybe like 25 years ago. Which is like where if you look at the tool chain, if you look at the practices, it's really where that is. So obviously that's not great. And we need to bring in what we have learned from shipping services, cloud services, and codes over to our machine learning practices. So I think there are like mainly 3 things I will focus on today that I think if we do well, we will move this industry to like the 21st century, if you will. And those are bringing the best practices that we have learned from code to the ML like workflows, and then meeting users where they are. It's not it can be very like an easy discussion to say, well, forget everything about how you ship ML. Just don't do that. Come over here and do what we do for code or services. Don't use notebooks. We don't, right? And we can just like, that would be an easy discussion, but then the world doesn't work that way. There is a reason people like using Jupyter notebooks. There's an easy flow of information, or like more intuitive to how they are approaching problems, how they're experimenting and prototyping and so on. So it's very important for this to improve, for us to meet the users where they are and improve their current tool chain or their current experiences using the tool chains they already want to use or like to use or comfortable using. I can't ask you to like stop using Python. It's not a production language. Go use C++. Right? It just doesn't work. So you have to go make Python that you use and love just work well with this flow.
So question, Hatem. Sorry to interrupt you. But when you mentioned that previously it used to take like 4 to 8 weeks to ship, right? Do you have any sense of like, has that improved now? I'm assuming since 2019 it has improved, but at what kind of improvements have happened? Do you have any idea around that?
I could not find more recent, like large enough surveys about this.
Okay.
I did find some companies, like big companies, Facebook, Google, I think Cruise, were reporting between a week or 2 shipping those models. I don't know if this experience translates to a wider range of companies, because these companies do this, what I'm talking about. Like they have processes and they have tools, they have like very huge investments in this area to make that experience like streamlined. That I don't think smaller companies or companies that are like just starting up get. And last thing, trust, right? And trust here means you trusting your code and the model, but more importantly, your enterprise and the product people who will benefit from the model can trust the process to constantly improve or gradually improve. Whether and this can be from I want to make sure the model I ship will not just like crash in production, right? Or when it does crash in production, I will know and it can roll back, and I will not like lose data or lose the code that I used to generate a model because somebody left the company, or because it was on somebody's laptop, things like that. So you want to make sure that when you increase this trust, when people can trust that you are shipping quality code or or that we can recover if something bad happens, it will enable people, enable like machine learning engineers to ship quicker, ship faster. And yes, things can break in production, but then if you are confident that I can recover in seconds, instead of trying to find who shipped this previous version, right? You will be more encouraged to ship quicker and like iterate faster.
Yeah.
And this is where I think Flight can help to like attack these three aspects. Flight is an opinionated platform. It focuses on the workflow orchestration part of this problem. And we'll talk about how it does that and how you can use those to achieve the three things I talked about. It has some primitives around reproducibility. It guarantees to make sure that the thing I ran like 2 months ago and produced a model 2 months ago, I can just go back to and rerun and get exactly the same model once again, right? I can just ship to production. It comes built in with like extensible model, is very observable with dashboards and alerts that have like sensible defaults. And it comes with the like shareability in mind. What we have seen, we developed Flight when we were at Lyft, is that people don't work in isolation. There were like 70, 80 teams using Flight, and they don't all just build their own thing. They, sometimes they build one model and they introduce like utilities that are useful that other teams start wanting to use. And instead of like reinventing the wheel, they can just like reference, what we call tasks and workflows across projects or across teams. And it just makes enables everyone to move faster because they are just like building sort of on top of each other instead of replicating everything just slightly differently on their own.
Yeah.
So go over a few concepts in Flight just so we are like talking the same language, and then we can talk about the these features. Flight comes with the logical grouping of your entities, something we call projects. You can map those projects to maybe GitHub repos or multiple projects in a repo, or maybe to teams, and you can have a project spanning multiple GitHub repos, like whatever the division is, but this is like a logical grouping of your entities. And then inside those, you have what we call domains, and those you can think of as like the CI/CD semantics for your entities. So you can like ship things that are still not production ready, and send them in a domain, maybe a development domain. So you are telling everyone, yes, I have this new piece of code. It's not ready for production. I can keep using it, and you can keep iterating on it, and people can experiment with it if they feel adventurous. But then you can like promote things to production when they are ready and when you're comfortable that they are ready for others to use. And there are semantics about how to move things around and so on. You can have like tests that run that like, gate test to make sure things are okay or like in a higher quality before they move and so on. And then the things you actually put in those projects and domains are what we call workflows and tasks. And those are the basic primitives or like building blocks that Flight has. They share some properties. They are both declarative, and what we mean by this is you write them in the language you're comfortable with, be that Jupyter notebooks, Python, Java. It's very, those are the languages that we support natively, but you can implement them. You can like maybe even have like a UI that lets you declare a workflow. It doesn't matter because at the end of the day, we need a protobuf definition. It's like our intermediate language. that once you have it, right, so you're coming from any language, you generate this protobuf definition, and then the rest of the system only looks at that declaration, right? They're all versions, so everything is immutable in the system. You cannot like modify an existing task, right? You have to register a new version of it, maybe following a git SHA, like so every time you commit to git, that's a new version, or you can use like semantic versions. You can use some versioning scheme, but the key thing is when you register something, that's it, right? You cannot go back on your words, which gives a guarantee for everyone else who depends on it that it does not change, right? You like the Docker image will not change, the interface will not change. I know I used this thing once before. A year later, if I use it again, I will get the same results, right? And then they have interfaces. So your tasks and workflows, they get, it's like you can think of them as functions. They get strongly typed inputs named with the specific type. There are like schemas, obviously, JSON schemas and whatnot, like more complex descriptions of types. But they are strongly typed, right? So at compile time, we can tell whether this task can produce something that this other task can use or not, right? So we can fail very early on. You don't have to wait for like weird runtime errors when you like update a task version, right? And you don't know if maybe they added a new required input or something, right? You will know all of this ahead of time as you're writing your code, and gives you like a lot faster iteration time that way. And then when you write a workflow, what you are doing is saying, I'm like describing a flow of data, right? I'm saying I want this input, pass to this thing, then consume the output here, pass it to this other thing. And when we look at a code example, you write it just like a Python function. It is a Python function that takes inputs and call other Python functions that may be tasks or workflows. And it's very composable that way, right? You're just, it looks like a regular Python program and it runs locally as a regular Python program. But when you compile it into our protobuf format, our intermediate language format, this is where we do the static analysis and figure out the flow of data and the graph, what the DAG looks like. And then it can run in a like a production environment with parallelism, because we also, since we know the inputs and outputs and the flow of data, we can decide that in this image, for example, this Python function and this Spark task don't have any like interdependencies. They can both run in parallel at the same time. So we will just do that for you. Whereas if you're running it in Python, of course, like locally, it doesn't natively do that for you. In flight, it will, right? There are dynamic workflows, and we'll talk about those in a second. There's also native support for what we call map tasks or array tasks, right? Those are, if you're doing, if you're familiar with like a map reduce style jobs, maybe in Spark, or you're doing them elsewhere. The flight also comes with like a native support for it, and it's like a lighter weight version. If you're just doing like massive parallel task, you can use this, and it's very scalable. It's like cloud agnostic. It can run on different cloud providers or locally. So it gives you a lot of like flexibility, maintaining the same semantics, and it's just essentially like you're running a map in Python, but it runs on a distributed system, right? In parallel, different containers and so on. And gets like with all of the tasks, you get like, retries, you get timeouts, you get like a lot of semantics that like by default could come with flight that guarantees, the behavior of your entire workflow. Then comes dynamism, which, what we have been talking about so far is like declaring the workflow in code is statically, right? So I like with one look at the code, I can tell what the graph is, what the tasks are, and so on. But there's this like very scalable feature. It's called dynamic workflows. So I can choose at any point in the workflow to say, I am maintaining the same interface, but in this node called D in this example, right, it takes these inputs and produce these outputs. But in order to do that, I need to execute this completely dynamically generated workflow that could be based on the inputs. Maybe I will look at the inputs I got at runtime and decide if I got more than 100,000 inputs, then I will run this map task. But if it's less, then I will just run it locally, or whatever the logic could be. You can choose or completely arbitrarily generate a graph at runtime and return that, as long as you are maintaining the I will take these inputs, I will return this output, right? The interface. And it's a very powerful feature. I've seen that used like almost in every workflow that I have seen people start. They will start with like a static thing, and then like days later they jump onto to a dynamic workflow, because it gives you a huge flexibility to reshape your workflow at runtime, essentially. Data catalog is another service that comes with Flight. It's a separate service. Flight is very modular that way. You can like always swap and replace components of Flight. There is like very documented and like strong service APIs between the different components. Data catalog is what we use for lineage and memoization. As the name suggests, it's a catalog of your data. So it keeps track of the artifacts that you produce or consume in your workflows and tasks. And that gives us two very powerful features natively. Again, memoization, which is, if I ran the same workflow again, I don't want the same task that took the same input to run again, right? We know it's the same task because everything is immutable. We know about the inputs because we have strongly typed interfaces. Yeah. So we can say, well, we'll skip it. Like the rest of the workflow will assume that the output was generated, and we already know what the output is. Here you go. It's very useful for debugging and retrying large workflows when you like modify a single node. They don't actually have to run again when nothing else has changed. So it speeds up your development cycles, but also what we saw very that ties back to the shareability. If I develop a task that everybody in the company starts using, you automatically get memorization, sharing the outputs sort of across the company, right? If one team runs it on like maps that were generated yesterday, and then 10 other teams start consuming the same task and passing the same data, they don't have to regenerate the maps again and again and again, right? They would just reuse the outputs. And then the other feature that this enables is lineage. Again, because the system tracks all the data that goes across between the workflow, between the nodes in the workflow and across different workflows, it can track the data way like up to the very first ingestion point that started the flow. So maybe this is like the row table that you got from like sensor data from a car, right? You then ran a workflow that did like sort of an ETL job, right? Transformed this and produced more tables. Then maybe some cleanup stuff, transformation stuff, right? And as long as all the data is being passed across through Flight, and then all the way to like a model training with a generated model at the end, you can tie all of these together with a very clean line, I guess, of dependencies, and you can track maybe when the data changed in that chain that caused maybe some model or data drift down the line or something, right?
So,
It's a
question.
very
Sorry.
powerful. Oh, go ahead, Paul.
Yeah. So one of the questions I have is, would it also, is there a way to also version the data itself? Because when you talk about like a specific row table being used, like, I mean, if there are changes and I want to reproduce that task, is there a system that you can create for that?
That's a great question, Pon. So Flight itself does not. What we, but there are integrations that other like community contributed. One of those is with a project called Don't, and this is exactly what it does. And there are a few of those projects that do similar things, but it's basically versioned tables, right? And it's like it integrates very seamlessly with Flight. You can just say that my input is adult table, and if this is your system, right, it will all be versioned. Everything will be tied to that version. Memoization will also follow the same, right? So it will know that if you have that table of that version, then I will produce this output. Lineage will happen, right? So all everything flows very nicely across the system. It's also a very swappable component, right? So it can be replaced with, maybe you can take that component from Pachyderm or some other tool that does versioning of data similarly. I think we have seen like in a couple of use cases that people started using Dolt like for exactly that, because it gives you like sort of an end-to-end experience, right? It's very powerful and cannot like beat that.
Yeah.
And then I think, last but not least, the reusability, right? So we talked about that a couple of times, but you can, since every task in Flight can have its own container. It can be containerized separately. It's everything that runs in Flight is containerized, except SQL queries. That there's just no code to run. But when you write code, you can just Flight is like not trying. It doesn't try to maintain your Python dependencies or requirements or any of that, right? I think we have seen other tools do that and not produce great results in corner cases. So we are like, we'll do containerization first. We'll get that right. It's a very clean way of packaging your code with your dependencies, be that native dependencies or Python dependencies. It also enabled us to be language agnostic, because if you're running Java, I don't even have Python dependencies with some Maven packages. So it's like a very clean contract between like Flight and the actual code that runs. So everything is containerized. You can have multiple different containers in a workflow, right? So every task can have its own sort of container that runs. And then you can share those tasks across, projects or teams or tasks and workflows. So they only need to know sort of the reference to this task, right? So they need to know which project and domain and which version they want to depend on. And once they know that, they can like run this again sandboxed or containerized thing in their own environment. And produce the results, right, very consistently. So no need to like figure out the the dependency conflicts between your code and their code. It's not a library you import. It makes it like a very clean separation. They can develop and update libraries and whatnot on their own, and you can as well, right? Very cleanly. You can also compose, your workflows of others' workflows. We have seen people use that a lot, especially in like the ML, the training part of the machine learning, like life cycle, where they have like maybe like a driver workflow that calls the training workflow and a test workflow and right a couple of other workflows that they can like iterate on separately. But then they have this Uber driver workflow that calls all of those. Yeah.
So one thing is one question I have is, so you have all these different pipelines, right? ultimately, are there unit tests or are there other checks or balances that you can put? Like, does Flight allow you to do that within? Is there a specific way of doing that?
Yeah, and I hope time allows. I want to show some of the examples of this. So there are a couple of ways you can ensure your code continues to like run correctly.
Okay.
Since it's just a Python function, there are ways you can do to like unit test it. So you can write like actual unit tests in your code, and they will run exactly the same as a Python function, right? You can do mocking, right? So if you have a workflow that runs, 10 tasks, and you just, and maybe they are external, maybe they're written by other teams, or maybe they are in your team, in your code, but they like maybe import data or like do SQL query. You don't want to, every time the unit test runs SQL connectivity, and right, so you can mock these tasks, and it's very neat, natural. It will become very intuitive to any Python developer. We try to use like as much as possible the same tools that like PyTest and like all of the tools you have in Python, and just make them work with our concepts or our constructs. So you can mock like the things that others produce, or the tasks owned by other teams. You can mock expensive tasks and whatnot, so that you can like the unit tests are more predictable, more consistently run. You can have type checks. So we also have integrations with pandas and great expectations. So you can check like at runtime the data that's coming in. So you can, I don't know if you have used great expectations before. It gives you a way to set your expectations. So you say, well, I'm expecting a table that has, these columns, and the value ranges for these columns are this and that, right? So you don't have to code for this. You just express your expectations. And then at runtime, these expectations will be like asserted, and the task will not even run if they're invalid. So, and there are a couple other ways to like, test your stuff, but those are, I think, the main ones we see people use a lot.
Yep, makes sense.
All right, so now you have written something, right? You have written a workflow, and you develop something, and it's running, and it's great. You have a model. What happens then? Because again, you have to babysit this, even in production. And Flight also comes with some of not native, like some built-in support for dashboards and alerts. We have dashboards in Grafana, and we're, if you are using a different system that's getting popular, please do contribute other dashboards. We publish a lot of metrics that can be leveraged in different systems, but this is just the one we used to use at Lyft. So we figured it, and it's open source. We figured it's common enough to make open source as well. But yeah, please let me know if you use different systems. So we have mainly like 3 categories of dashboards. We have like cluster health, about the actual cluster where the code is running. We have our control plane, the admin and propeller dashboards that tell you the health of Flight itself. And then the most commonly used one is the user-facing dashboards that tell you a lot of information about your workflows that you wrote. Maybe the CPU memory consumption, if you like reserved some capacity, how much of that are you actually using on like a regular basis? Failure issues, like does my task fail a lot? Maybe I wrote a task that other teams use, and I don't see failures in my project, but when people use it, they see failures. And then you can like start drilling down into, maybe they have like weird inputs that you don't expect, and start coding in it, right? So you get like a lot of information about statistics about your code and tasks, workflows, and so on. And we see people use that a lot to debug, to reduce cost, to like track and reduce cost, and to like optimize their usage of resources and like latency. We've seen cases where people looked at one of their workflows, and they were like, they were running a task as a map, and it has its own overhead, starting containers and so on. And when they looked at the dashboard, they were like, each like entity in that map takes seconds to run. There's no reason I would run this as a map, distributed map, right? So they like immediately changed that to like a single task with a loop, and it was just like much faster, right? So these are things you will not like. You can't intuitively know by looking at the code, right? Because you don't know the inputs. But looking at the runtime actual dashboards, you can infer certain things. And then, yes, we talk about observability. There's sort of like management operations that you can do, because all of the flight is sort of a managed service. It runs in your company, but it's like your company will like host it in a cluster. There are some knobs that we give to the operators of this like deployment. They can set quotas, right, for each project and each user. That you can say, you only get, I don't know, 1,000 CPU a day. So it limits costs. It avoids like noisy neighbor problems. So you don't have one user that takes over the entire cluster. So it gives you a way to like share also resources across people. So from like a company perspective, we've seen the companies like this because they don't have to maintain a separate deployment for each team. At the same time, they can share resources and so on, and guarantee availability to these teams. There are we manage authorization through IAM and similar systems. In Kubernetes, it's through K8s service accounts. So you can centrally manage like a policy-based authorization model. You don't have to run with a single like God role, everything that runs. You can run every like execution with a role that's like limited to what it needs access to. Maybe every team has a separate role, like you can partition it any way you want. But it's custom, right? It's separate and gives you fine granularity to access resources that you need access to. I've seen installations where you have maybe teams that do like finances and so on, and you don't want their data accessible by other teams. And this is all possible given like one deployment because of the fine-grained, IAM rules. There are secret access, right? So you can deploy secrets and use them. Maybe you're talking to a third-party service from your task, right? You can securely deploy secrets and access them only in the task, only at runtime. They don't show up in the code. They don't show up in Git. They don't show up in our UI. They're only accessible to your task at runtime. And there's obviously the dashboards and so on. We looked at earlier for your DevOps to look at. You can share tasks and workflows across the entire company. And we have a few tools for debugging too. And try to go quicker to show you code. This is similar. This is one of the pieces of the UI. You can see the inputs, the failures in the UI. We try to pull the call stack and so on, and the exceptions and whatnot what happens, so you can see them right in the UI and debug your stuff. There is support for logging and different logging services. So right from the UI, if you integrate with like CloudWatch, Stackdriver, and so on, you can just see those logs immediately linked in the UI. And then finally, extensibility. So Flight is very modular and very extensible. You can replace any component, definitely, but more commonly, we see people want to extend. I want what you have. I just want to add this one little feature. And there's this sort of flowchart that guides you through what do you want to do and what kind of extensibility point you want from just adding a richer type, right? This is how Greek expectations and Dolt and Pandas integrations were added. Or I want to customize what the container does. So maybe I want to run SQL. I want to write my own SQL task, and it only runs in the client side. Or I want a more managed resources that run. I want to control how many of those resources capacity I have in the cluster, and who has access, who has priority, and so on. There's a backend plugin you can write for that. You can write also like completely new language, your own DSL on top of FlightKit. And we've seen a couple of companies do that too, to control what users can write. They don't want them to just write any, arbitrary complex workflow, but very specific ones that do like, a couple of queries and like publish function or something like that. So they wrote their own DSL, and you can easily do that on top of FlightKit as well. Yeah, so little bit more information here, but yes, I want to open it up for questions, but I have, I think, 5 minutes before I have to do that. So let me pull up some of the sample codes just to show how do I do that.
So at this point, I encourage people, if you guys have questions, please do post them. Don't be shy. Yeah, it can be specific to flight. It can be general about like how to build machine learning pipelines, whatever you may think about. Okay, so please do feel free to ask questions. I mean, I do have my set of questions, but I'll sort of save it for later.
Awesome.
Yep.
Yeah, so this is our documentation website, just showing a couple of very basic samples. This is a normal Python function with type hints, and you just add a task on top, and now Flight knows that this can be packaged separately, can run its own separate container, and it will deduce the interface from the type hints, so it knows it takes a string and returns a string. Similarly, you can write a workflow same way. It can call multiple functions, multiple other tasks or other workflows, just like it would call a function. And again, it has inputs and outputs. Those can be very, arbitrarily complex. You can add tons of those, or you can use a schema with like a complex structure as inputs or outputs. And you can locally run it just like a function, right? Because it is a function. We will, if you run it locally, we just pass this along, but we'll do the extra checks as well to know if you are, Python lets you maybe like default inputs to your function inputs. Flight doesn't. Python also will not really error if you return an int and you say I will return a string. But when you run it this way, Flight will add these checks locally, so you get more of these errors as early as possible before you run remotely, right?
Yeah.
There is a lot of tutorials here in user guide that we try to categorize into a few of these categories, like depending on what you're trying to do, from just the basic stuff, like the different components, different concepts. There is control flow. You can run conditions. You can run map tasks. So you can like compile and run conditions, statically compile conditions, I would say, that can be evaluated at runtime. Map tasks are like very easy to run. They're very similar to how you would define a map task, a map function in Python. Just say, oops, sorry, I went to the documentation. Just say map task with the function or the task that you want to like map on, and you pass in the inputs that you like, the array of inputs, right, that you want to map on, and this now becomes a map task that will run on a distributed system on however many inputs you have, and you can define additional metadata and so on. There are more complex examples, and some about the different integrations we have and how you can extend Flight and so on. So I would really encourage you to go to docs.flight.org. A ton of information, a ton of examples. You can just like copy paste and start running with. There's also a guide on how to get started, right? So just like installing Flight, writing your first workflow and getting it to run and so on. So anyway, I would love to open it up for questions now.
Awesome. So I'll start off. looks like our audience is a little shy today. One question is, where do you notice, like, building machine learning pipelines, right? Where do you notice that breaks happen? Like, at what point do usually things break?
Sorry, at which point do you think what?
At which point do machine learning pipelines break usually? Like, what is the point where it usually fails, essentially?
Oh, when do they fail?
Yeah.
Yeah, so I think we saw that. It's a great question. I think I would say there are a few points where a few triggers where people realize that they need even a pipeline, like right, or a system like flight, right? And we will start with that as the basics, right? Because it's very easy to say, well, I will fetch data, I will train and publish a model, and I can write that in a function,
Yep.
right? And it's very hard until you see the failures that we'll talk about. It's very hard to convince you otherwise, right? So and I will like say two things here. It will fail, and you know that. But the thing I want to say is one of the goals, again, the meet the users where they are part, right? One of the goals of Flight, and I hope other similar platforms, is not to change how you are developing your stuff normally. Just adding a little bit of sugar on top that will make it a lot better, give you a lot more value,
Yeah.
right? So for when do they fail, or what do they, at which point do they fail? We have seen that from cases where people who do develop a lot, like locally and so on, it can be very hard for productionizing those workflows due to very mundane issues. Things from, I don't have access to the data when I run remotely because of the roles I'm running as. Things like that, like, I don't really want to deal with this in the 21st century. This is just work, right? And we've seen, things that fail very late in production when the models start showing, like, giving bad predictions, right? They're running inference for fine for a couple of months, then things start going weird, and you realize that maybe a retrained model was pushed. If somebody like retrained on data that was maybe not pruned, not cleaned, they didn't run the cleanup workflow for it first. They just write things like that. And again, because this process is not codified, like, it's usually sits in somebody's head or a document somewhere, right? It's not enforced or not easily reproducible. People miss things, right? This is human nature. So and then it's usually very hard to go and correct them because you don't even know what the correcting was to do.
Actually, I was going to say that probably many a times it's not even logged. Forget about, like, it being, if it's not even logged that the new model has been pushed, how do you even know that, something new has been pushed? That you're just running and you're thinking, okay, why is my model failing? Like, if I take the same data set and run it locally, it works fine, but in production it's failing, like, massively. So I think that's a really important point, right? And that sort of leads me to the second question, is that like, on the production side, right? Like, how do people utilize Flight, as you've observed?
How do they do what?
How do they utilize Flight
Utilize
on the
Flight.
production side?
Yeah, so we Flight so far, and there is no reason it cannot expand to that. It doesn't do serving. Like, we tried very hard to not, like, reinvent the wheel. There are tools that do things very well, and they do it right. They do, like, the one thing and do it very well. We just integrate with them, like Spark, for example. Right, Spark is insanely popular for data processing and very quick, very efficient caching and all of that. So why do Spark again? Same thing for Flink. Why do we, like, Flink is very popular now for the real-time processing of notifications and stuff. Why do it again, right? All of these tools do great at what they do. They just the Flight came to integrate all of them together so that it's very intuitive for an end user to pass and like pick and choose the right tool for this particular step they're trying to do. So on the same note, right, serving, I think there is a lot of good tools there, KF serving, Seldon natively, and so on. They do this very well. So Flight doesn't try to replace it. We have seen the typical workflow we have seen is people write teams that do just data processing, write their own workflows in Flight. Teams that do like the training, they use Flight. They write like workflows in Flight. And then somebody in between writes a workflow that calls like this entire pipeline that would use a particular model. And this becomes the standard for producing this model, right? So every time you want to retrain it or you want to like ship new code or whatever, you just run this one workflow. It's like a codified standard, right? It will always work. It's like, this is what we do, right? And then it ends with serve, right? So like some function, some task that just publishes the model to be served through one of those tools. But potentially Flight can also integrate more natively with these tools to give you many better insights, or maybe can like do monitoring, model monitoring, and so on for you. With like detecting data drifts and biases and whatnot, like so it can like give you richer information and maybe richer checks before publishing things to production.
I see. Yep. Looks like everybody understood everything in terms of questions.
Well, it either means I did a great job and I just clarified all the questions they have in their heads. I hope it is true.
I think you did a wonderful job. Seriously, like I think there's a lot, but I also think that this is a new thing, because I think a lot of people have to understand the process. I think people are having a hard time enough, wrapping their head around how to train ML models in the first place, than to sort of, deploy it, or even to train it at scale, right? So I think this is an important step forward, and it's going to be, as we go along, it's going to be crucial in ensuring that organizations large and small are successful in maintaining their pipelines, building effective pipelines, and making sure that they deliver value. And the statistic that you mentioned earlier was really alarming, right? Like, I mean, if you're taking 4 to 8 weeks to just build and deploy a model, then where are you going to go as a business if you have 50 million users
exactly
your product, right? Like you can't hire a bunch of people.
It doesn't scale.
It doesn't scale. So you need tools like Flight to make sure that these processes are smoothed out and you have the right way of doing things. So with that, I would like to thank you for coming, and I thank all our attendees. Thanks, guys, for being here. It has been a really nice talk. Thank you so much. So, have a good day.
Thank you. And thanks, everyone, for being here, too.
Thanks. Bye.